All right, welcome. So we are going to be going over this SPSS activity together here. So this activity details a one-way ANOVA. So we're going to talk through this activity. I'm going to show you kind of both the assignment and the SPSS. We're going to kind of be switching back and forth between the two. All right, so let's take a look first at the actual assignment document. And if we look at this, we can kind of see what's going on here. So this can be found in this week's module again. So make sure you have this and an SPSS window open as we kind of go through this together. All right, so where are we with one-way ANOVAs? So we're kind of taking a step up from our t-test activity that we did last time we did an SPSS activity. If you recall, when we looked at t-test, those required us to only look at two levels of our variable. Now that we have, in this case, more than two levels of our independent variable, we need to use what's called an ANOVA. And this is going to allow us to look at multiple levels all at once. And so in this instance, what we have is a group of researchers that are looking to test a blood pressure medication called High-Blox. And they are predicting that this medication is going to help reduce blood pressure. But to test this, they did a couple of things. They took a group of people and they decided to have them all be male participants so that there weren't any gender effects going on. And they split them up into three different groups. So one group was given a high dose of this medication, High-Blox. The other group was given a low dose of the medication. And then the final group was actually just a placebo sugar pill. So they didn't receive any of the medication. What they did after taking the medication is they had a couple different measures of the participants' blood pressure. So they took the blood pressure, scratch that. I'm thinking of a different activity. So they had one measure, they took the blood pressure of the participants. Okay, so what they were hypothesizing was that high dose would lower blood pressure the most, and that the placebo would have the least effect on blood pressure. So let's take a look at the three questions here before we get into SPSS and just kind of look through what we have going on. So the first question is asking us, what is the experimental design of the study? Remember, we have within, between, or mixed as our choices. And so within being all participants receiving every level of our independent variable, between being separate groups for each level of our independent variable, and a mixed study design requiring multiple independent variables, some that are within and some that are between. So for this study here, we have three separate groups, each experiencing one level of our independent variable. So this is going to be a between subjects design. Our independent variable here is going to be our dose of High-Blox with three levels, high, low, and none, or placebo. And our dependent variable is going to be blood pressure. So I'll just put this here, dose of High-Blox, and our dependent variable is going to be blood pressure. All right. And again, that is between as our study design. So this is the information or the data that we're going to be moving into SPSS. So I'm going to switch over to that, and I'm going to kind of be bouncing back and forth between the two as we go through and put these variables in. So we're going to start like we normally do in our variable view, and we're going to set up our variables first and then kind of go from there. Notice also that we don't have a participant number here. We're going to kind of skip that step for this example. However, normally I do like including that, as you've seen in your own data, as a way to reference back. But for this instance, we're just going to do these two variables, dose and blood pressure. So I'm going to make the first variable here be, dose. And the second variable is going to be our blood pressure. Remember, again, you can't put spaces into SPSS, so I like to just capitalize the first letter of each word. We're going to check our first three columns, make sure those are set correctly. They are both showing up as numeric variables with a width of 8 and 2 decimals. So if we take a look at our data, we can see everything is numeric that we are entering. We also don't have any individual cell that has more than 8 digits or 8 characters long. That's our width limit. And we actually aren't dealing with any decimal places, so I'm going to go ahead and reduce that down to 0 just so that our data in SPSS looks exactly the same as it looks here. So again, I'm just going to reduce these decimals down to 0, and that will let our data look the same both ways. All right, so we're also going to talk about the measure real quick. So how are these measured? We have dose and blood pressure. So our dose measurement here should be ordinal, being the case that we have separate groups technically, but those groups are in some order, that being high, low, and none for the dose of high blocks. Blood pressure, on the other hand, is being measured on a continuous scale, so we know that we can use scale for that. Let's also talk about the values column next. We're only going to need to deal with that for our dose variable, being that we have 3 values, 1, 2, and 3, and each of these representing one of our labels, placebo, low, or high dose. So let's go ahead and put those labels in that section in SPSS. So again, once I select the cell that I'm looking at, values for our dose variable, I can click the box here, and that's going to pull up my window that I need. Once I'm here, I can click the plus to add in the different labels that I have. So in this case, a value of 1 is the label placebo. So I can put 1 label being placebo. I can hit the plus to add a new line. A value of 2 is going to be my low dose, and add one more. A value of 3 is going to be my high dose. And again, I'm just taking this information and putting this in to that section. If you're working in an older version of SPSS, this box will look a little bit different. You should just kind of see these already appeared. I don't think you have to hit the plus. You just kind of have to work your way down the table and add the values and the labels in. All right, once we have all 3 of those in, we can hit OK, and that is going to close that out. Let's also just add a label here for each of these. All that labels do, I don't think we've talked about labels yet. All labels do is just give us an alternate way to kind of, well, label our variable. If you remember, the variable name itself has these kind of weird rules to it, like you can't have symbols or spaces or things like that, but those rules don't apply to our label. So if we wanted to kind of be more detailed or just make things look a little bit cleaner, we can do that in our label section here. So for example, dose, I'm going to label this as dose of high blocks. And blood pressure, I'm just simply going to do blood pressure, but with a space so it looks a little bit nicer. And you'll see when we switch over where these labels start appearing. All right, with all of that entered in, we should be good now to switch over to our data view, and we can see our variables appear at the top here. Notice this is still using the variable names, not our labels that we just entered. All right, so what we should be good to do on this next step is to take our data from the assignment and copy and paste it into SPSS. So again, we're going to see if SPSS cooperates with me today. Remember, when pasting, if it's not working, there's a couple things you can try. Number 1, make sure when you paste, you're on the top leftmost cell and that you just single select so you have this gray box. You don't want to be pasting with a double click where you are actually in the cell. You want to just single select that so that it is gray. And you can try either the keyboard command of Control V, or if you're on a Mac, I believe it's Command V. You can also right click and try to paste this way. Notice this actually isn't working for me. Or you could go Edit and Paste. Now, sometimes SPSS just kind of takes a minute because we're working off of the server to kind of catch up with the fact that you've copied something on your computer. If it's still not kind of showing after a minute or so, what I recommend you do is you try first the keyboard shortcut of Control V or Command V and see if it does anything. Sometimes that kind of triggers it to check and see if you've pasted something. If that still isn't working, eventually, I think that actually did work for me. It didn't actually paste anything yet, but it kind of triggered it to check and say, okay, did you have something copied? And it found it here. And now if I paste we get my values appearing. All right, remember also that our labels are now appearing like this. You may not be seeing these. You may still be seeing 1, 2, and 3. If you're seeing those, we can always use this button at the top here called our value labels button to switch back and forth between our numerical coding and the labels that we assigned to each of those numbers. So I'm going to leave it on this for now, just because I think it looks nicer. But remember, we always have our numerical ones that we can reference here as well. All right, let's switch back to the assignment and just kind of take a look at where we are at. So we've put all of the values in. We've done everything we need to up until step 5. So step 5 has us conducting a one-way ANOVA. So let's go ahead and run that. And you can follow either these instructions or watch as I complete this. So to run my ANOVA, I'm going to start where I always do, under Analyze. And if you recall last week, or I guess it was a few weeks ago, whenever we looked at our t-test SPSS activity, we started with compare means and proportions. And you'll notice all of those t-tests are appearing here, right? This is what we ran last week. Notice also that we have a one-way ANOVA appearing here as well. This is primarily because these are very similar tests. The only real difference is that ANOVAs are able to look at more than 2 levels of a variable, whereas t-test can only look at those 2 levels at a time. And since we have 3, placebo, low, and high dose, we know we need to use an ANOVA. So I'm going to go ahead and select my one-way ANOVA. Again, Analyze, compare means and proportions, one-way ANOVA. That's going to bring up my dialog window. And again, I have 2 spaces now that I can put my variables into. So what this may just make sense to you, but our dependent list is going to be our dependent variable. So we can kind of start there and identify blood pressure, if we recall, as our dependent variable. So I can take that and move that into our dependent list. And then my factor is going to be my dose of high blocks. It's also a good point to point out. You see our labels are now appearing first, and then in the brackets is the actual variable name. So again, just a way to label things and make it look a little bit nicer or easier to identify. So we have those 2 variables in now, but before we run this, let's do a couple things. Number 1, let's go to options and let's include our descriptives. I always like doing that. I like to see my means and standard deviations. And we're going to need those when we write our results up, so it's good to include here. So I'm going to go hit check that box, and then I can hit continue. I also need to do one more thing. I need to go to this post hoc button, and I'm going to need to include a post hoc test. Now, there's a lot of different ones we could do. And what a post hoc test does is after we get done running our main analysis or our main ANOVA to tell us, is there a difference between blood pressure somewhere amongst these 3 groups, our post hoc test breaks down each possible comparison and tells us where that difference is coming from. So we need this if we find a significant main effect in order to identify where those differences lie. Now, the 3 most common that I've personally seen are either the LSD, Bonferroni, or the Tukey. For this case, we're going to be using the Bonferroni. There are some different reasons why you would choose one over the other, primarily because of sort of the thresholds that they use to identify significance. Bonferroni looks for sort of very stringent thresholds, which for drug trials, medical trials, things like that, which in this case is what we're looking at with blood pressure and medication, it's often used for those instances. So we're going to choose Bonferroni by checking that box, and that's going to allow us to run that post hoc test. So that's all we have to do is check that box and hit continue. So again, we've put our variables in. We've included the descriptives under options. We've included our Bonferroni test under our post hocs, and we should be good to go ahead and hit OK and run our ANOVA. So if we do that, we get our new output window. I'm going to try and shrink this down a little bit. So we get our new output window here, and we see it looks like 3 different tables. We get our descriptives table here, actually 4 tables. We get our descriptives table here, again with our means, standard deviations, and actually some extra information as well for our 3 different groups. We see our main ANOVA table. This is going to tell us our main effect of our independent variable on our dependent variable. We get our effect size table as well. And then down at the bottom, we see under post hoc tests, our multiple comparisons. So let's go ahead and break these down and talk through each thing that we found. Let's go back to our assignment sheet and look at the set of questions that we have to answer. Okay, so we're going to start by looking at the descriptive statistics box. And question 1 is asking us which of the 3 groups had the highest mean blood pressure. So if we look under our descriptives table, we can find the mean and look for the highest value, and we can identify that highest value being our placebo group. We have placebo, low, and high dose. Total is just going to add them all or average them all together. So the answer to question 1 is going to be our placebo group had the highest mean blood pressure. Then which of the 3 groups had the lowest mean blood pressure? Again, we can take a look at this box and identify that the lowest value here of the 3 would be our high dose variable. So we can go with high dose, which means that our low dose is going to fall somewhere in the middle there. So we kind of know already the direction of what our medication is doing. The more the medication, the lower the blood pressure, which does align with our hypotheses, but we need to look farther at our analyses and find out, are these differences significant? Maybe they're really close and not really significant, or maybe they're far enough apart that we can say that this is a significant effect that we're finding. So let's go ahead and look at the next output window or the next output table that is the main effect of our analysis. And we can take a look at this question and identify what values we're going to be looking for. So we're looking for our F value, our significance value, and our effect size or our partial eta squared. So if we switch back to our main ANOVA table, we're going to find that using these 2 boxes. So the main ANOVA table, oops, didn't mean to do that. Our main ANOVA table is going to give us, by looking at our between groups line, that top line, it's going to give us our F value and our significance value. And then to find our effect size, you'll see over here, eta squared. We're looking for that point estimate value. This 0.610 is actually that partial eta squared. So let's go ahead and move these values into where they go on the assignment sheet. So our F value is going to be 9.375. So let's put our F value here as 9.375. Our significance value, or our P value, is going to be our significance here of 0.004. So we can put 0.004 in right there. And then our effect size, or our partial eta squared, since this is a one-way ANOVA, partial eta squared and eta squared are going to be the same thing. So we can look for, under our effect sizes, our eta squared value, and the number we're looking for here is this point estimate. So 0.610 is going to be the value of our effect size that we want to report. So again, 0.610 for our effect size. Let me just do this to kind of make things stand out a little bit better for you guys trying to view this. All right. Next question is, were the independent variable groups significantly different from each other? So this is kind of our main question, right? Was there a main effect of that independent variable or the dose of the medication on our dependent variable? Was that blood pressure different across our 3 groups? And to answer this question, we're going to look at our main ANOVA effect, or this main F value and main significance value. And if it's below our cutoff, in our case 0.05, then we would say that it is significant and there is a difference between our 3 groups. So if we look at this significance value, 0.004 is definitely less than 0.05. So we can say here that, yes, they were different. They were different from one another. And how do we know? We know this because the significance or p-value was less than our cutoff of 0.05. And again, that tells us we have a significant finding. Now, all that tells us, though, is that there's a difference somewhere. So it doesn't tell us the order or where those differences are coming from. Maybe two of those levels or two of those groups are different from one another, but two of them are not, right? So we need to kind of take a look deeper using our post hoc tests to identify where that difference is coming from. So I'm going to do this by looking at the next set of questions. So question 5 asks us, which of the groups were significantly different from one another? And again, we're going to interpret these findings basically like we would a t-test. So what I mean by that is if we look at our next table down, or our last table here in our output, our post hoc Bonferroni tests, each of these lines is one pair of group variables. So what I mean by that is this top line is comparing our placebo group to our low dose group. The next line is comparing our placebo group to our high dose group, followed by low dose to placebo, low dose to high dose to placebo, and high dose to low dose. Now, because of kind of the way this is structured, there's going to be some duplication here. Notice, for example, if I take low dose to high dose, we get a difference of 7.6. And if I take high dose to low dose, we get a difference of negative 7.6. So it's the same gap between them. We're just changing the order. And that order doesn't matter in terms of our significance value. So what we can really do is just find the three pairs or the three lines that we are interested in. The first time you see one of the pairings of variables is what you want to pay attention to. I mean, it really doesn't matter which you choose. You just need to pick one. So in our case here, we're going to take this first line and look at how the placebo group and the low dose group compare to one another. And we can see that their significance value is 0.031. The significance between those differences is 0.031, which is less than 0.05. So we can identify that there was a significant difference between our placebo and our low dose group. So let's go ahead and mark that one down. So placebo and low dose were different. Let's actually say were significantly different. Let's take a look at our next line, placebo and high dose. Again, if we look for that significance value, we have 0.004, also significantly different. So I'm going to go ahead and report that here as well. Placebo and high dose were also significantly different. And you know what? Just so that I have this information, I'm going to mark down the significance value here because I'm going to need that later on. So 0.031, 0.031, and I believe this was 0.004. Was that it? Yes, 0.004. Now, if we go to the next line, you'll see it's low dose and placebo. Now, we've already looked at placebo and low dose, so we don't need to report that one again. So let's skip that and go to the next line. Now we have low dose and high dose, and that is a new one we haven't looked at. And if we look across, we can see the significance value for that comparison is 0.823, which is not less than 0.05. So we do not have a significant difference there. So even though the question doesn't ask to include this, I am going to just for your sake, so low dose and high dose were not significantly different. And again, we had a p-value or significance value here of 0.823. And again, what we mean by interpret these findings like you would those in a t-test, essentially, these are three separate t-tests that were run. So we have a t-test comparing the placebo and the low dose, one comparing placebo and high dose, and another t-test comparing the low dose and the high dose. And we're just looking to see in each of these which ones are different from one another. And again, we find differences between 2, but not between a third. All right, so we've got 2 more questions left. Let's go ahead and answer question 6, which is really to kind of wrap everything up, right? So overall, what are the conclusions of the results of this study? So what are we kind of saying or drawing from these findings? So are the dosage levels all effective? Were part of the experimenter's hypothesis confirmed? What kind of is going on here? So I'm going to go ahead and just kind of describe this one and then let you guys kind of explain this one on your own. So really kind of what we found was that there's a difference between the placebo or no medication and both of the 2 doses, right? But we didn't see a difference between the low and the high dose. So what this tells us is it doesn't really matter whether you got the low or the high dose. As long as you got some amount of the medication, you were going to have reduced blood pressure compared to the placebo group or those not taking any of the medication at all. So again, didn't really matter what amount you took because again, no difference between low and high dose. As long as you took one of those, you would have significantly decreased blood pressure compared to not taking any of the medication. So I'd say part of the hypotheses were confirmed, right? They did predict that the high dose would lower it the most, but they were wrong in saying that there would be a difference between the high and low dosages. So just kind of keep that in mind when you're explaining this. Part of the hypothesis was correct, being again that high dose component, but not fully because there was no difference between low and high dosages. So again, I'll let you guys kind of describe that and answer that question on your own based on what we just talked about. And that leaves us with the final question here being question 7, which is going to have us do a formal APA write-up. Now, we're going to kind of follow this example here as we go and write up what we found for our main finding. So we're going to start by reporting first our overall main ANOVA, and then we're going to break down those post hoc tests that we have here and discuss those as well. So let's start off by saying something like a main effect of high blocks was found on blood pressure. Again, just start off with a normal sentence that explains what was found. So we did find a main effect in that main overall ANOVA of high blocks on blood pressure. Now, we also want to include our statistics at the end of this sentence. And again, for an ANOVA, we're going to be using an F value. We're going to come back to the degrees of freedom that are in the parentheses here, but let's just find and report what the value of F was. Again, we can look here on our assignment and say the value of F was equal to 9.375. So I'm going to come down and say is equal to 9.375. Our p-value here was equal to 0.004. So let's go ahead and do our p-value was equal to 0.004. And we can report the actual p-value. We can say it equal to because we know the value is right there. And then finally, we need to include our effect size. Again, I don't like finding that symbol and re-entering it in here. So what I do is I use this example and I just highlight that and copy it and paste it down here rather than having, again, to find that symbol. Oops, not like that. And again, I am going to say that this was equal to our effect size that we found. So 0.610 is going to be our effect size, 0.610. It looks like it changed my font here. Let me just kind of fix that real quick back to our default. Okay, So that is our main overall finding, but we need to include our degrees of freedom in the parentheses following F. Now notice for an ANOVA, we actually have 2 degrees of freedom, 2 values here to report. So we can figure these out kind of without using SPSS, but we can also find these in our output. So the first number is going to be basically the number of levels of our independent variable minus 1. And so if we have 3 levels of our independent variable, minus 1 is 2. We can also find this on our between groups line in our main ANOVA. So we can see our degrees of freedom here are going to be 2. So we're going to report the first number as 2. And the second number is actually, again, sort of something we could identify here. It is going to be the number of participants minus 1. You can also find this here under the total degrees of freedom in our main ANOVA output. So again, we had 15 participants, minus 1 is going to give us 14 as our other degree of freedom value. So it's going to be 2, 14. And it's similar to other degrees of freedom we've reported for t-tests and for correlations, where we have the value related to our participants. But we also need this extra number now because in a correlation, you're always comparing 2 variables. In a t-test, you're always comparing 2 variables. However, now in an ANOVA, we could be comparing multiple levels of our variable beyond 3. We could look at 4, 5. We don't know. So we need this number to tell us and identify how many levels of our variable are in this ANOVA. So we have 2, being that we are using 3 minus 1. All right, so we have our main effect reported here. So the next thing we're going to do is talk about our post hoc tests. So I'm going to say something like post hoc analyses indicated, indicated that there was a significant difference in blood pressure between the placebo group. Did we freeze? Hopefully that's still running. Okay. Between the placebo group, there we go, and both the low and high dose groups. So I'm kind of including 2 comparisons here in one sentence. So I'm saying that these post hoc analyses indicated that there was a significant difference in blood pressure between the placebo group and both the low and high dose groups. So I'm comparing both the placebo and the low dose and the placebo and the high dose group here. So what I need to do now is I need to, well, let's just finish writing this last sentence and then we'll go back and add in all the numerical values. So my last sentence is going to be something like, however, there was no significant difference between the low and high dose groups. So again, I'm now reporting this last one here. So I've covered all 3 of these, the first 2 in one sentence together, the next one in its own sentence. So I have everything reported, but I need to go back and add the values that I need to include. So I know that I'm going to need to include my means and standard deviations for each group, as well as these p-values that I kind of reported or wrote down here when discussing each of those comparisons. So let's just kind of follow along this sentence and figure out where we need to put values in. So post hoc analyses indicated there was a significant difference in blood pressure between the placebo group. All right, so right after I mentioned the placebo group, I'm going to include my mean and my standard deviation. And both the low, so I now have my low dose group here. Let's just do this. Between the low and high dose groups. So I'm going to do my high dose group right here. And however, there was no significant difference between low and high dose groups. Now, we've already reported the low and the high dose values here, or we will in a second, so we don't need to re-report those means and standard deviations again, since we've already mentioned those values once before. So this is the where we're going to put those three values in for the placebo, low, and high dose descriptives. So let's go ahead and find those values. Let's start with the placebo group. The mean and standard deviation of the placebo group we can find in our descriptives table, that first table in our output. Our mean and standard deviation for placebo is going to be right here. So 139.4 and 14.17, 139.4 and what did I say, 14.7, 0.17. So we've got our, again, mean and standard deviation for our placebo group. Let's do the same thing for our low dose group. We're just going to look for low dose here, mean and standard deviation, 119.2, 119.2, and our standard deviation is going to be we'll round it to 7.3, 7.73. And then finally, our high dose group goes here. So the mean value for our high dose group was 111.6. And the standard deviation for that group, again, high dose standard deviation is 8.36. 8.36. So now we have our means and standard deviations for each of our groups. And then now last thing we need to do is add in these p-values where relevant. So we're going to say that post hoc analyses indicated that there was a significant difference in blood pressure between the placebo group and both the low. So the placebo and the low, we're going to include the p-value here. So I'm going to put this as p was equal to placebo and low 0.031 and high dose. So I'm going to put that here. P was equal to 0.004 groups. So again, if we just kind of read that, we're saying that the p-value or the significance of 0.031 is comparing the placebo group to the low dose group. Let's just say low dose. That might be a little bit more clear. So between the placebo group and the low dose group and the high dose group. And we're putting the p-value for the placebo and the high dose groups here. However, there was no significant difference between the low and high dose groups. So I'm going to add my p-value for this is equal to 0.823. And again, I'm pulling that right here. So we've now reported everything we need to include: our main effect, our F value, degrees of freedom, our p-value, our effect size. Our post hoc test breaking down all three comparisons with descriptives and significance values for each comparison. The last step we have to do, like always, is go through and italicize each of these symbols. So the letter P in each of these significance reports, we're going to italicize. We are also going to italicize our M and standard deviation, or SD, in each of these. And we are also going to italicize in our main ANOVA both our effect size, which should already be italicized, as well as our p-value, or just the p itself, and the letter F. So again, now all of those statistical symbols should be italicized, and everything should now be reported correctly in APA format. And with that, that should complete the assignment and complete this activity. Make sure also when submitting this assignment, You also include your output. For this output, you should be including these 4 tables: your descriptives, your main ANOVA, your effect size, and your multiple comparisons or your post hoc tests at the end. Again, screenshots probably work best for this. You can include that in your document or separately, and just go ahead and make sure you get all of that submitted.